question direct to my team and I. They know what we do for them. But what can active leaders in optics and photonics do for us? The answer is simple. By joining Optica as a corporate member, you encourage us to expand our trusted global network and support our new range of services. Get deep insights into what's next for your sector in photonics with free access to over 90 market reports, plus exclusive access to the PowerPoint slides for the in-person meetings. And corporate members get exclusive access to all Optica industry meetings in 2024, including our Executive Forum during OFC, the Freeform Optics Industry Summit in Rochester, New York, hosted by Optimax, the Advanced Manufacturing Industry Summit at SUS Micro-Optics. If you're an investor in photonics, you'll recognize where I am now. Hello from Frankfurt Messe. Voor de ICO Conference.
Ja, maar als je onderin de lijn, onderin je beeld, zie je daar.
In Silicon Valley. The Optica Laser Congress in Osaka, Japan. Plus the Optica Quantum Industry Summit, this time in Bristol, UK. And remember, being a corporate member of Optica also gives you discounted access to many partner events, such as Peak Summit Europe, Driving Vision News, and Peak International. Optica is always listening to the changing needs from end users across the world. On Tuesday, March 19th, our 2-hour online industry meeting will examine their needs in laser micromachining. Diverse sectors like automotive, jewelry, watchmaking, biotechnology, semiconductors, textiles, and consumer electronics all have one thing in common. The challenging demands of precision manufacturing are tightly coupled with the need for rigorous efficiency and scalability. But getting things right first time presents formidable obstacles. Take automotive, where laser micromachining is key in making precise components. There is huge pressure from clients to optimize production speed without compromising quality. That's because product recall is the nightmare scenario for car manufacturers. Similarly, in the jewelry and watchmaking sectors, precision is synonymous with value. End users deal with the delicate balance between achieving complicated designs yet maintaining cost effectiveness. And in biotechnology and semiconductor manufacturing, the quest for ever smaller components demand cutting-edge laser technologies capable of sub-micron precision, pushing the boundaries of current capabilities. In the consumer electronics sectors, where smaller and lighter is usually better, partnerships with suppliers offering precise beam shaping capabilities can accelerate sustainable product development. So if you are a manufacturer of ultra-fast lasers, laser diodes, specialty fibers, laser optics, if you want manufacturing equipment for assembly and test of laser systems, or if you are looking for the right laser for the right application, then do not miss the chance of making meaningful connections. Prepare your answer to the Optica question and then join us at 7 AM in Seattle, 10 AM in New York, and note the slightly earlier starting time of 3 PM. On Tuesday, March 19th, we will hear from the following companies: Aconeer, Disco, Microrayeos, Turner Laser Systems, Coherent, Luxinar, Lasea, 3D Micromach, Oxford Lasers, Amplitude Lasers, K-Labs, Direct Machining Control, Little Asphericon, and all the way from Vilnius, Lithuania, Light Conversion. Since to stay ahead, you need to collaborate, the Optica question has never been more relevant. So let's start hearing answers now. Indeed, right now, let's start hearing answers. Thank you very much for joining the Optica online industry meeting on laser micromachining. Today we are global. We have people from all over the world. Over 300 companies have registered for this meeting today. Some of them are joining in the Zoom room, others are joining in YouTube, and most important, all of them are here because they want to connect with each other and find ways to do things they cannot do easily themselves. My name is Jose Pozo, and I'm here talking on behalf of Optica. Optica is the global platform for optics and photonics. And today what we are doing is to help our corporate members succeed by providing them with market reports, events, access to talent, and access to investors. Today is a very important day for us, not only because it is the second event of the online series for the online industry meetings, but also it's just 1 week before OFC. And we are all very excited of the best, most important event of the year. Please, if you haven't registered yet for the executive forum, please do it. We had the best agenda ever made. But also, that I'm here talking on behalf of the Corporate Engagement Council. These are the people who tell us what to do, people leading our industry association, and of course, talking on behalf of our president, Professor Pierre Loix, president of Optica 2024. As I said before, today is our second day of the online industry meeting series of 2024. Today is laser micromachining. All of you active in the business of datacom telecom, write down 30th of April, Andy Berhosheim from Arista, and the rest, they're going to talk about linear drive optics, removing the DSP from optical transceivers. But today is all about laser micromachining, and we have a fantastic agenda. As I said in the intro video, we have companies who are the integrators, the companies who were here. They come here offering something to the rest of our members, Disco, Lasea, Coherent, Aronia, Luxinar, and Tunnel Laser Systems, and the companies who come here with a solution, an enabling solution, Little Oxford Lasers, Amada, Tech, K-Labs, Direct Machining Control, 3D Micromach, Amplitude, Asphericon, and Light Conversion. And our job today is to connect them, to connect companies. And talking about connecting companies, I would like to tell you about one big initiative of Optica. Many of you have heard this. Optica is building the Global Advanced Manufacturing Alliance. These are all the companies in the Optica membership who are active in optics manufacturing. And you can see them here in the center of this slide. All our members are looking for metrology, materials, integration into different systems. And that's what we're providing them. We're providing them with contacts with different companies who provide coatings, who provide different materials, optical design, software, but also with potential customers in the field of laser diodes, photonic integration, data and transceiver, cameras, tomography, everything that the companies in optics manufacturing have to do. This is the Global Advanced Manufacturing Alliance. All the companies in optics manufacturing are going to find ways to connect with potential suppliers and with potential customers. Our kickoff meeting, for those of you who are interested in this, our kickoff meeting is in Neuchâtel, Switzerland, at the House of Focus Light Switzerland, formerly SUS Micro Optics, on the 25th and 26th of June. Be there. And let me look a little bit deeper into this slide. Let me zoom in the laser part. Here are the companies who are corporate members today who are offering laser technology to the optics manufacturers. Thank you very much for all the support. I expect to see you in Neuchâtel on 25th and 26th of June. And having said that, I would like to say that this meeting today is live streaming YouTube. So let me say hello to the YouTubers in the room. Hello, YouTubers. Please, if you have any questions, write them in the chat and I will read them in the Zoom room. And that's, of course, also valid for the people here with me in the Zoom room. This meeting is about making connections. So if you have any questions, write them in the chat or in the Q&A button, and you will voice the question yourself. And all of you, please prepare your answer to the Optica question. What can you do for them? And what can they do for you? I think it's time to get started. It's time to get started. I would like to give the floor to a person who, in my previous job, was featured in many of our online events because he was working for a very different company. Today, Benjamin Bernard, is here representing Optica corporate member Disco, and he joined the meeting as an integrator and user looking for partnerships. Benjamin Bernard, thank you very much for kicking off our laser micromachining online industry meeting. The floor and the attention of over 300 companies is yours.
Thank you very much, Jose. Thank you for having me. So let me share my slides. Can you see them?
Crystal clear.
Perfect. Yeah, then konnichiwa and arigato gozaimasu for having me here. My name is Benjamin Bernard, and I'm working for the Disco Corporation. So who is Disco? We are a Japanese company. Our headquarters and R&D center is located in Tokyo, and all our production is in Japan. So we have three main plants, the Kuwabata, Kure, and Chino plant. But you cannot only find us in Japan, more or less you can find us everywhere our customers are located. So we have a pretty bright worldwide footprint, as you can see in Asia, Korea, Taiwan, Philippines, Singapore, and China. In Europe, where I'm located, the head office is in Munich, and of course in the US on the West Coast as well as on the East Coast. Overall, we have roughly 6,000 employees, and we could sell quite a couple of units already successful to customer. So what are our key technologies? We call them KKM. KKM stands for Kiru, Kitsuru, Migaku, which means dicing, polishing, and grinding. Wafer manufacturing process we address, and mainly the back-end processes. So the grinding of the wafer until you reach the final thickness, and then do some polishing to have the desired surface condition, followed by wafer singulation and also package singulation. We have grinder, polisher, and blade dies in our portfolio, but I want to concentrate on our laser applications. For the laser applications, we have quite many different approaches. So on the left side, you can see the ablative laser approaches, mainly laser grooving and laser full cut. I will have a slide on it later. In the center, you see the non-ablative approaches. Here you highlight stealth dicing, where we teamed up with Hamamatsu-san. More or less the idea here is to focus inside the material, do a modification, do many of these modifications along your separation line, and then later on by applying an external stress, you can separate the wafer. We also have a Cabra, which addresses the wide bandgap wafer production. I will have a dedicated slide to that at the end, so I will come back to that later. Last but not least on that slide, we have the laser lift-off, mainly gallium nitride grown on a sapphire substrate, and then you want to lift off the gun. So we use a laser to focus precisely on the interface between those two materials, and then you can lift off the gallium nitride layer from your bulk material and transport it wherever you want to have it. So focusing about the laser ablation, and what kind of process strategies are we offering? So the main application in the semiconductor industry for the laser is still the laser grooving, followed by blade dicing. So more or less the laser is used to remove some sensitive top layers or PCM structures like metal structures, gallium nitride that is hard to dice with the blade. This you open, more or less you open the dicing street for the blade cut, and then cut the bulk material by the classical blade dicing approach. Very similar, but a little bit changed in the sequence is the dicing before grinding approach. So here you do the laser grooving in the blade, half cut, still in thick wafer condition, and then you grind it back, and by tape expansion, you can release the chips into the individual dies. The third one is the laser full cut. I mean, the idea is obvious. You completely cut the wafer with the laser. So you focus on your top side and remove material until you finally cut through. Another approach, you see there's quite a lot of synergies between laser grooving and different approaches, is stealth dicing before grinding. So more or less you do the stealth dicing modification from the backside. But if you have on the pattern side some metals that are hard to expand, then you need to remove them also with the laser. And last but not least, we teamed up with an American company called Plasmatherm, who is providing plasmatizing equipment. So shout outs to my colleagues from Florida. And here the idea is that with the laser, we can remove, again, metals that cannot be plasmatized, or also to open the resist. You can also use our spin coating as a resist for the plasmatizing, and then the laser grooving opens the resist at the positions where you want to interact with your plasma. One example I want to show you for a classical grooving process is here. So gallium nitride, white bandgap material. And for the grooving process itself, it's key to not create a significant thermal damage zone on your bulk material, because after the blade cut, this will reduce your mechanical robustness of the die to succeed the subsequent process steps. But as you can see here, if the conditions are correctly chosen, then you get very clear and defined cutting edges, a very smooth roughness of the surface, defined grooving depths, and also for wafer-to-wafer bonding application, it's important to have very little recast or burr, because this transfers then into a larger area that is not bonded on your device. The last slide that I have is focusing on the silicon carbide wafer production. So due to the electrification and the need for many inverters, the white bandgap materials gained a lot of attention lately. And the classical approach is you grow the silicon carbide in a chamber. So you have a certain boule, and then you cut with a wire the silicon carbide wafers from this ingot. We thought we have a better solution using a laser to focus inside that ingot, creating the so-called Cabra layer. And then by some subsequent process steps, you can get your wafer split from the ingot. On the image here, you can see our fully automated tool. More or less, you can store several boules, several cassettes for the wafers. Of course, you need to do some, after one wafer splitting, you need to do some preconditioning of the surface to make it optical in good condition again. But this tool can do it all in one line. And compared to the classical wire saw, we could reduce significantly the process time to generate these wafers. Also, due to the precise and gentle interaction of the laser, we could skip some process steps, so you don't need to do so much preconditioning after the splitting. And finally, which really is directly money in the pocket of our customers, we can reduce the curve loss. That means that material that is wasted when you cut silicon carbide from the ingot. So that is our approach for the silicon carbide wafer production, and then we call that Cabra. Yeah, since I just had 6 minutes, more or less, I'm almost through. So as you can see, we try to work really on the cutting edge. We have good relations with all our customers, and we are able to integrate the newest technologies into the semiconductor device manufacturing market. So please keep in mind, Kiru, Kitsuru, Migaku, Disco. Thank you very much.
Arigato and Dankeschön. Dankeschön,
Yes.
Benjamin. Thank you very much for a great presentation. It was really fantastic. This is an Optica meeting, so I need to ask you the Optica question. What can you do for the others, and what can others do for you?
Yeah, I mean, as you can see, Disco has a very long history of creating tools for high volume manufacturing. And of course, we're eager to learn the newest technology approaches and then bring them into mass production or integrate them into our tool. So we would be really using the cutting edge technology and bring it to customer.
You're looking for cutting edge technology. Let me try to do that. We have been seeing in many applications that pulse shortening and actually controlling the length of the pulse has been a big challenge in different semiconductor applications. So allow me to bring to the table one potential partner for you, Christian Frisch from N2 Photonics. Good afternoon.
Good afternoon, everyone.
What brings you to a meeting on laser micromachining?
So basically, we want to introduce our small startup company, N2 Photonics. Am I allowed to share the screen already? Is it working?
100% allowed.
Perfect. So yeah, let me begin with our short introduction. So first, a disclaimer: I took over the meeting from our other co-founder Oleg, who is unavailable today. So sorry for the mess, Jose, I caused you.
Not a problem.
We are a small startup company from Hamburg, in Germany, where we were founded in 2022, and the core technology of our business is, as you mentioned, laser pulse shortening or laser pulse compression based on nonlinear optics. For that, we developed a product. Basically, we're starting with a commercial industrial grade laser system that you're already all familiar with in the femtosecond range. And usually when the industry is talking about femtosecond range, we mean hundreds of femtoseconds, so around 250 femtoseconds, 300, 400 femtoseconds. That is something that is commercially available from many suppliers. But what we can do now, we can shorten these pulses by extending the frequency range via cell phase modulation and compressing the pulses in the time domain down to 50 femtoseconds or even shorter, depending on your needs. And this way, optimize your application. The technique itself, the physics behind it, has been known for many years. However, it hasn't made itself, it's not available in the industrial application yet, because it used to be driven in optical fibers, and coupling a femtosecond laser to an optical fiber is always a challenge, especially when you do it on, I want to do it on top of a machine or in a shop floor somewhere. In our system, we're not using optical fibers, we're using free space propagation only, which means our system is very robust for misalignment, for any kind of fluctuations. It doesn't get damaged if something goes wrong. And we really want to enable this way the industrial applications. Why do we think that going to even shorter pulses does give the user new chances or enable new applications? There are mainly two things that we can focus on, and where we're convinced that it gives you a net benefit. And the first one is that the ablation threshold is reached more easily. So more energy that's contained within the pulses above the ablation threshold actually does work on the workpiece. That means you can run your process either with lower energy and higher repetition rate at the same average power. So you have more productivity because you can run it faster, or you have improved surface quality, as we will see later. I'll show an example there. The example that I want to show you was done in collaboration with one of our customers, and it was presented this year at Photonics West in San Francisco for the first time. Let me run you through this exemplary setup. We start with a femtosecond laser source from light conversion. In this particular case, it was a carbide system. We used a beam expansion telescope to adjust the laser to our module. It's called MIXT, a German abbreviation for multipass impulse compressor Stufe. It's a single stage system. We compress the pulses down to 67 femtoseconds. We have a broadband polarizer and thin film polarizer to form an attenuator. Guide the whole beam through another telescope to make it larger for smaller spot size, to a scanner head and an f-theta lens onto our target. The whole commissioning of the system took around 2 days. Why, you would ask, it takes 2 days? Well, the complicated part that we actually performed for our customer was not delivering the 50 femtoseconds right after the laser system. That's the easy part. The challenging part is to do all the dispersion pre-compensation such that the short pulses actually reach the target. And this is what you can see here in the end of the optical chain is a measurement that we verified that the pulse duration is actually, in this case, 57 femtoseconds on the target. What our customer did with that unit is run various material processing experiments. And the most notable one that I wanted to highlight here is cutting or machining squares into fused silica. It was a pre-experiment just to explore the parameter space. And what we've seen here is that the surface quality itself within the square is more or less comparable between all the pulse durations. So from top, you see long pulses, 2 picoseconds, and short, you can see compressed pulses, 57 femtoseconds. And for the long pulses, we have kind of frayed edges, not very clean edges. And the shorter you go, the better the edges become. So 270 femtoseconds, this would be the current industry standard, so to say, for femtosecond lasers. You still see the frayed edges. However, if you go down to sub 60 femtoseconds, you start to suddenly see very, very clean edges of these squares. So for us, what this proves is that there is some advantage to using shorter laser pulses for micromachining that we could provide for basically any industrial grade femtosecond laser
Thank you
system.
very much for that, Christian. It was really good to hear your shortening of the pulses, but I want to hear from a person who has been shortening pulses for semiconductor applications for many years, and now with Disco. Benjamin, is this exciting?
Yes, it's I think very, very nice, and thank you for presenting this. I mean, do you also have some values in terms of the ablation rate? Can you see a higher ablation rate using 50 femtosecond pulses compared to 340 or 800 femtosecond? That would
So
be also interesting.
ablation rate itself, I can't comment on that yet. So just to give you a bit of more perspective, this was more or less the first customer experiment that one of our clients did to verify it for material processing. We ourselves, we are not laser micromachining experts. We do laser development. We can't do the micromachining in-house. That's why I can't give you these hard numbers. However, I would, if you're really interested, I could establish the contact with our client, and maybe he can give you more insight on that.
Maybe one second question. You mentioned it was easy to integrate your unit, but it was a little bit harder time to compensate the dispersion. So how do you think for industrial tools, is this a challenge to keep it stable?
It's only complicated if you do a one-off system. So if you have, for us, it was a new scanner head, new beam expander, new F theta objective we've never worked with. We didn't know the exact dispersion curve, so we had to do it more or less experimentally. However, if you want to integrate it into a machine and build 10 of those and have always very similar components, the pre-compensation is pretty straightforward.
Thank you very much.
So, Benjamin, if you're interested in actually having a simplified way of assembling a laser, there's a company in Optica which has attracted a lot the interest of end users on that. Let's go to Lithuania to meet the company Litilit. Nerijus Rusteika, are you with us?
Yes.
It's so great to see you. Nerijus, for many years, you have designed well-designed, affordable, very simple lasers on the femtosecond and picosecond laser regime. Tell us what you brought, and let's see if we can match maybe an interest from these condies.
Yes. Do you see my slide already?
Very well.
Very well. Okay, excellent. So, hello, everybody.
Hello.
Like Litilit.
Nerijus, we're having some problem with your sound.
Sorry.
This is the beauty of doing the meeting live.
Okay, is it sound not working?
Much better now.
Okay, I'll try it. So, I'm not sure how long I have a presentation. I thought
1 minute.
1 minute, excellent. So at Litilit, I think first of all that everybody in this meeting agree that laser micromachining is the future of precise manufacturing, right? So starting from there, our company Litilit has very clear vision to bring femtosecond lasers, which are enabling technology for microprocessing, to the commodity level. In this way, we seek to advance the industries by offering well-designed, reliable, and affordable femtosecond lasers. Today, I would like to introduce our newest development, Indilit 20 laser. It has optical parameters specifically tailored for micromachining applications, for many of which medium average power level, but relatively high pulse energy, excellent beam and pulse quality are required. The laser is unique in the market by providing 20 watt of average power and 130 microjoule pulse energy in a very compact, robust, and thus protected, passively air-cooled package. We firmly believe that for micromachining. If you want to be convinced, contact us regarding trial tests. This is it from my side.
Thank you very much. One thing that we would like to go back to Disco about, in many different ways, we have been discussing about the difficulty of integrating lasers and using standoff components. From the point of view of Disco, do you see a challenge? Do you see a potential solution that can be solved by simplifying the laser system?
Yeah, I mean, in general, we're trying to keep it as simple as needed, but as complicated as it has to be. So yeah, I understand your question, but hard to comment. I mean, in general, yes, simplification is good, but certain process steps need some.
We have discussed your potential suppliers. I'm going to go now to your customers, or I hope the ones that I want them to be customers. I'm going to take you, Benjamin, to a beautiful city in Belgium. The city is called Liège, like you speak Flemish. And this city is a city that has a fantastic river, fantastic bridge, and a fantastic company in the business of laser workstations. I'm going to Lasea, and Jose Ramos is the director of R&D at Lasea. Jose, muchas gracias. Merci beaucoup. Thank you very much for being with us today. Tell us what Lasea does, and let's see how we can provide you with potential partners, suppliers, and customers today. The floor and the attention of everyone goes to Jose Ramos from Lasea.
Thank you very much, Jose, for your kind invitation and introduction. It's very, very nice to be again in one of your events. I'll try to share my screen. Hope it's working now. Can you see?
Gorilla Glass clear.
So I will try to very briefly present what we do at Lasea. And for that, I will follow this summary. So just a very brief introduction to the group, because we are a group, not just the headquarters that are based in Liège, as you said. What are the type of solutions we provide through our machines? Some examples of applications to understand better those solutions, and finalizing with just a very brief vision of our research activity that help us in advancing in our technology. So, as I say, we are a group with main facilities, with productive facilities in Belgium and in France. So main headquarters are in Liège, but we have also production facilities in Mons, in the other side of the Wallon region, also in Belgium. But we have also facilities near Besançon by Laser Cheval that make parts of the group, and also near Bordeaux by our Lasea France subsidiary. In total, we had around 8,500 square meters dedicated for production, with more than 180 employees. I should highlight, just to go a little bit fast on the figures, the number of more than 30% of average growth per year in the latest 12, 13 years. We have as well facilities in Switzerland and in USA. Together with other representatives, we develop our activity in the 5 continents. Here we represent the countries where we have already installed machines, and we have more than 3,000 machines installed around the globe. So we like to say that we provide a solution, not just a laser machine. We provide a solution that is based, of course, in our expertise, that is very broadly developed around the use of femtosecond lasers. But again, as we say, we provide a solution. That means that sometimes we integrate other type of solution, other type of laser, depending on the application, together with other characteristics, and always around providing a very, very accurate laser system, laser solution. How does our laser solutions look like, our machines? So these are just a selection of few of them. And with, for example, the more in the left, the most recent concept of machine developed for high accurate and high productivity applications. But we have other solutions, like, for example, for research, upright, or developed in the frame of research activities, like the multiplex prototype managing 64 beamless in the same system that is installed in Aachen in the Fraunhofer ILT as a result of an R&D project. Examples of applications we find many, for example, in the area of medical field, and here are a few of them. They are mainly used for implant manufacturing or other devices, for example, for intraocular lenses or cochlear implants or catheters. But we find also many applications in the precision micromechanics, in particular for high-end watchmaking, as we can see here for example, taper microcutting of components, or very complex 3D engraving, or turning very accurate parts down in the picture, amongst many others. For example, in traceability for electronics or pharmaceutics, wire stripping, conductive layer removal, or ceramics processing. Also for electronics, the right down. Well, ending with some figures on our research activity. Well, we try to develop a quite significant research activity in order to keep our competences and our solutions at the top end. Those are mainly oriented in improving productivity, versatility, or accessing new areas of applications with our technologies. And this, we do it very often by being involved in collaborative research projects. And here I have selected a few of them. Many of them already finalized, and others that are still ongoing, like Metamorpho Operatic or Syntex, in very recent topics. To conclude, well, to say that we provide efficient and reliable high-precision laser solutions for micromanufacturing. Our solutions replace more polluting production methods, so we help in achieving more sustainable production. We help as well in developing solutions in the area of miniaturization or functionalization of surfaces, allowing the design of new or more efficient or improved products. We do this using cutting-edge technology and with a collaborative and innovative spirit. All this help us in providing laser solutions that help in progressing in the field of microtechnology. So thank you very much for your attention. If you have any question, I will be happy to try to answer it.
Thank you so much, Jose. Jose Antonio, this is actually very good, because Lasea can produce like all these solutions for medical, for electronics, for watching, machining, like high precision parts and all these things. So that's actually very, 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 very good. Thank you so much for coming here. The first person that I would like to come here is going to be Martin Knowles. So Martin Knowles is the CEO of For Laser. So just right here, my neighbor. I'm in Manchester. He is in Oxford, and he can actually present some of the solutions for that, because it's Oxford Laser's solutions laser actually. So Martin, can you please come to the floor?
Hi, Helena. Thanks for inviting us. I'm delighted to be here today and have the opportunity to tell you a bit about the exciting things that we do at Oxford Lasers. Helena, I believe you have the presentation ready to go. Do you?
Yeah. So
okay.
Let's play it. And the sound.
Oxford Lasers has 46 years of innovation in the laser business and over 30 years in laser micromachining. We produce laser micromachining tools incorporating femtosecond, picosecond, and nanosecond lasers, and covering wavelengths from UV to infrared. Understanding the customer's needs is of paramount importance, so we have extensive applications facilities with 20 laser micromachining systems where we can work with customers, achieving sub-micron tolerance, and offer everything from feasibility studies through to 24/7 production. Key applications for Oxford lasers include laser drilling of ceramic plates for the probe cards used in semiconductor wafer test. These have rectangular holes, 50 microns in size with zero taper, and corner radii of less than 3 microns. Also for the semiconductor industry, we supply tools for high throughput active laser trimming of precision analog integrated circuits. In the pharmaceutical sector, we offer a laser drilling service with holes down to 2 microns in diameter to create known leaks in packaging and certified with a flow measurement. This is known as Closed Container Integrity Testing, CCIT. A developing area of innovation is the use of ultrafast lasers to weld glass to glass and glass to metal for quantum devices. We also provide general laser micromachining processes, including thin film ablation and cutting, all at high precision. If you would like to know more, then please visit our website, oxfordlasers.com. Thank you.
Okay, thank you so much. So that was exactly 1 minute. So this is like timing wise is actually very good. So thank you so much for give the solutions to our members. So there are some questions that are coming out. So there is so the oops, I lost it. Okay, so Daniel Sati from DIY Optics, he has a question to Lasea. So Daniel, can you please open your mic and say yourself your question?
Sure. Yeah, I've seen in the presentation. Hello, everyone. I've seen that you have a 1 kilowatt average power femtosecond laser. What is that used for? Hello?
Yeah.
Okay. Yeah. Now, okay. Could you please repeat your question? I catch just half of it. Is about integrating 1 kilowatt femtosecond?
Yeah, sure. I've seen in the presentation, in your Lasea presentation, that you can build or have an option of kilowatt average power femtosecond lasers. Is that
probably you have seen it in the slide about research and development activities, of course, have the experience to have integrated those power levels in femtosecond lasers in the frame of some research projects. As far as I know, and maybe I'm not updated, there are not commercial 1 kilowatt femtosecond lasers available at this time. But maybe we can clarify this point today. I don't know, but according to my information, at least industrial grades. But we've been involved in several projects dealing with 1 kilowatt and above ultra short pulse laser levels. Hyperdias, multiflex, multipoint, lampas, for example.
Okay. What is the
and for taking advantage of it, yeah, I can tell you as well that, of course, we cannot go just focalizing those power levels and we get an improved application. It's not the way. We need to handle it, to do some advanced engineering depending on the application again.
All right, thank you. Maybe a follow-up question if you're already there. What is the average power you are using? I always hear that people are going for more and more average power. Is that actually needed or required by your customers?
Well, I think we have integrated already just about 100 watts. Again, it depends on the application, and not all the applications require with the nowadays technical solutions higher power level. But this is evolving. This is evolving. And for example, I mentioned 2 or 3 other projects that are still ongoing, like Syntex, Metamorpha, and Operatic, where we are trying to make more mature those technologies that we need to put into place in order to start taking advantage of the next level in power level. Going, for example, to 200, 300 before achieving the kilowatt.
All right, thank you.
Jose, maybe you don't know one thing quick. Maybe you don't know, Jose, what do-it-yourself, what DIY optics, do-it-yourself optics is. Daniel, could you tell us in a few words what this project is about?
Yeah, so basically DIY optics is a R&D services for optical system design. We often work with customers who want to use lasers for whatever purpose, injection molded manufacturing or ablation of dental application, for instance, or some kind of other laser scanning. Yeah, not just micromachining, but all kind of applications. We kind of design these systems, design the beam shaping, select the lasers, select the optics for the application, design the optics for the application.
Daniel, it is great to have you here in Optica. You are the CEO of DIY Do-It-Yourself Optics there in Switzerland. Great to have you. Helena, do you allow me to ask something to Jose?
Sure.
Jose, the application in which you were looking for high power, was it related to welding?
For me? Is the question for me?
Yes.
Yes.
What was the application when you required the 100 watts of power?
We had several projects, and one of them, the first one in period, was about ablation of silicon.
Okay.
We had another in the removal lacquer on a flexible steel plate. Well, not on welding.
Allow me to bring to the table one company that can help you with some of these high power applications. The company is Amada Weldtech. Brennan de Cesar. Brennan, thank you very much for being with us. Could you tell us what you do and maybe how you could interact closer to a system integrator such as Lasea?
Yeah, of course. So I think actually Lasea and Amada are fairly similar. I guess first I should introduce myself. I'm Brennan de Cesar. I'm manager of advanced technology at Amada here in California. So similar to Lasea, we focus on system integration. So I think Amada is well known for laser marking and laser welding capabilities, but we've also been very active in the laser micromachining space for about 15 years now. We focus on precision applications spanning multiple industries with a particular focus on medical devices and microelectronics. And so today we offer a full range of femtosecond laser micromachining systems, and these allow us to kind of access these different markets. And these are all built here in Los Angeles. Yeah, it's been a really exciting time the past few years, especially for an integrator like Amada. We are in that fortunate position where we get to explore and test new technologies being offered by innovative vendors, including many on this call, while we also then get to work with our end users, providing guidance and sharing in their growth and success. So as our customers turn more and more to laser micromachining, it's just been really important for Amada to keep exploring new technologies and building up our labs with the most capable lasers, optics, motion, and software solutions. And the partnerships that we've cultivated with our vendors have been, essential in making this possible. And likewise, our collaborations with our customers, they keep us sharp and they force us to keep growing and improving. It's actually really hard for us to define a typical application today. It could be anything from cutting or drilling sub 10 micron holes or features into a micro antenna made out of an exotic alloy, all the way to cutting an implantable device that is made out of, an organic tissue. And underpinning that mission of growth at Amada, it's our perpetual focus on world-class applications. So our engineers are the ones who bring all this specialized equipment in and learn how to use it at an expert level so that we can keep developing laser processes that bring our customers' visions to life.
Thank you so much. So I saw you, do you have any slide for where you are talking a little bit on your presentation? And meanwhile, I would like to to find someone that it will be a very, very, very good a connection with you. That's going to be direct machining control. So we have do we have open direct machine control? What is it?
Yes, hello, I'm here.
Yeah, hello. Yeah, I cannot see you. Yes, thank you. So yeah, could you please?
So we actually go ahead. I was going to say
Yeah,
we
no,
actually
go
work
ahead,
very,
please.
Yeah, we work very closely with DMC, and they've been a really great partner to us.
Okay.
Okay, thank you. So I will share also one slide with a bit of information.
Yes, please.
Yeah. And okay, so I will start by just telling what is DMC, and DMC is a software for laser processing system control. It takes in a CAD or geometries and allows you to define the process logic, and then it controls all those different devices that you can see to do an application. So DMC is also hardware independent, works with a wide range of control systems, various devices like cameras, sensors, lasers, and it can take care also of the complete machine control, or sometimes just some integrated subsystem. The applications that we support as well are very wide ranging, and from additive manufacturing to various laser micromachining cases in semicon, medical, electronics, and then all the way into complex 5-axis system control, freeform surface processing, sometimes involving robots. And in terms of capability, DMC can easily handle simple applications, but then it has a lot of advanced capabilities. So going from left, like freeform shape processing, kinematics, working with 3D CADs, the integration of sensors, scanning the surfaces, adapting processes based on that, camera integrations with machine vision. DMC has its own vision algorithms, and then to complex control where we can control multiple systems simultaneously, load balancing, special strategies, or cases where we need to process millions of objects, rows to satisfy some throughput requirements. And then the last question, how can you use DMC? And there are 3 ways to do that. And you can start with a standard interface, which is very flexible and perfect for application development. Then you can, of course, integrate that into your own application, or we can develop a custom HMI for you. So basically, DMC can take care for the whole way from application development all the way to the fully integrated industrial solution. And that's my quick intro of it.
Thank you so much, Saruna. So this is very good because actually we have here like a lot of lasers. So coming back a little bit to Brennan. So Brennan, what do you need from the lasers? So what exactly do you need from the lasers? What do you need from the laser manufacturing?
Well, most of our applications today require femtosecond lasers. It was discussed before, but we do focus on very clean, very short pulses. Some of the applications are so sensitive that the difference between a 250 femtosecond pulse and a 500 femtosecond pulse is actually notable. And then from the controls side, we're finding more and more that we really need advanced control systems, not just for motion, but also for coordinating the motion systems with the advanced galvanometers, multi-axis scan systems. So really the full range of integration equipment is really essential to making sure that our systems work properly.
Yeah, thank you so much. So I'm actually asking in the chat who can help Amada, and please react on that question, so that would be also to help to connect. One of the other things that we have to take in account, because this is very, very, very critical, is also what is going to be the beam shape that we are going to take. So the best person to talk about that is Wen from Kylab. So all welcome for Brittany. So Wen, the floor is yours.
Hi, Helena. Can you hear me well?
Very well.
Perfect. Great. Give me a second to share my screen. It's really cool to be here. Hi also, Jose. Always nice to spend time with you guys. Impressive, actually, the number of people who join. No? So,
okay, your sound is a little bit distorted now. Sorry.
Yeah, can you hear me now?
Now better.
Yeah.
Yes.
Yeah. Okay, cool. Is it full screen?
Yes.
Okay, perfect. Great. So K-Labs in short, you can recognize Helena, the building on the top left. This is where we are. We are actually a French company who is developing beam shaping systems. What we developed since the beginning of the company 10 years ago is what is called MPLC, for multiplane light conversion. And this is what you can see actually on the left, an example for telecommunication. The idea is to provide something which is quite unique. I have to make it short, so I would just say that this is not a DOE, this is not a freeform optics, this is not also beam shaping in the laser, this is multiplane light conversion. And it provides different performance, optically speaking. You can see, for example, on the top right, an image when you're defocusing with a system of ours or with something which is based on diffraction, the beam will just behave very differently due to the technology behind the beam shaping. So the idea is that because you have different performances, it can also enable different things. And actually, the idea is also to develop solutions which are available and compatible for the industry, I would say, and the constraint of being inside the industry. So I'm pretty happy that in the end, I can come after the Lasea talk, for example, because in my opinion, actually, kilowatt lasers is actually the future, but it needs proper beam shaping, because one beam with so much energy, because generally it goes with high energy, not only high power, is actually pointless. I guess everybody agrees on that in the room. And the idea is to shape it properly. So we are working on that, and we provide solutions which are industrial to do this beam shaping up to kilowatt femtosecond lasers. And that's what you can see on the right. This is results that we have had with Amplitude, for example. And the idea is to find the right shape to properly use the available energy, and to really look for huge upscale. So we are not, this is 17. You just go from Gaussian to square, and you can drill those riblets, which is surface texturing, 17 times faster. But this is not it. We target to go at least 200 times faster compared to the state of the art by doing beam splitting and beam shaping. So what we provide is actually the capability to really upscale processes using super high power and super high energy femtosecond lasers. I don't know if I made it 1 minute, but I think it was quite.
You did it good. You did it very, 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 very good. And thank you so much. And actually, yes. So one of the things that is not that much discussed yet here is what is going to be the right shape. Because depending on how it's going to be the material, how it's going to be the application, what is going to be the energy and everything. So it's going to be variations on that. But now talking more about lasers, let's go all the way to Germany. In that case, although they are everywhere, this is a company that has all kind of colors and energies and shapes for lasers. This is Coherent, and the product line manager, Fabian Sores. And Fabian, could you please open the floor for you?
Yes, thank you very much. Thanks for the kind introduction, and thanks for the opportunity to talk today. So let me share my screen. You should see the slides now.
Yes.
Okay. So I will not be able to present all of what Coherent is doing and providing to the industry in 6 minutes. So I will focus on a more detailed topic, which is actually a cooperation, a partnership that Coherent has with the ILT Fraunhofer in Aachen, called the UV Center of Excellence. And I titled the talk UV lasers from excimer to ultrafast lasers, because that's what this center is focusing on. And before that, please allow me as a product manager to talk a little bit about products. So Coherent is a DPUV or UV company since many years. We have been developing all sorts of laser sources, from CW and QCW systems to ultra short pulse lasers, and of course, high energy, really extreme high energy systems in the UV and the DPUV that have been in the industry for decades now and have been sold in very high volumes to the market. focusing on two products, and specifically in the solid state design for lasers. We have the Hyperrapid NXT product line with several thousands in the field with the 266 version. We have the Monaco femtosecond laser with a UV version. And of course, I would say today the pinnacle of solid state lasers being the Python with up to 2 joule single pulse energy or up to 4 joule with the twin Python. So these are the sources that Coherent can provide, and we are really with a strong expertise in designing these laser systems. However, what we needed and what was really needed to help the industry move along is a center or a place where these lasers can be made accessible to customers, to people who want to investigate new applications. So 6 years ago, Coherent started a cooperation with the ILT Fraunhofer, first for excimer lasers, and 2 years ago, we expanded this cooperation to include ultra-short pulse lasers as well. The idea here is that the expertise of Coherent providing these lasers, designing these lasers and make them available to the ILT Fraunhofer in Aachen would be combined with the capability and knowledge of the ILT when it comes to system technology, robotics, and specifically to diagnostics and analyzing applications. So today, the ILT Fraunhofer and UV Center of Excellence on site have multiple laser systems, not just standing around, but actually in tools available to researchers, available to customer requests to investigate cutting-edge applications, but mainly investigating the next generation of laser micromachining applications. And this with comparing UV with deep UV, comparing femtosecond with picosecond, or directly comparing ultra-short pulse lasers with excimer applications. And this is something that is not easy to do elsewhere in the world. There's only a few places where you can really do this with the same samples on the same ground, on the same conditions, making one-to-one comparisons. And a few examples of application results are shown here, where we have, for example, Benjamin talked about it from Disco. They're doing this as well. This is a real application today already in the industry, laser liftoff of gallium nitride for transistors. And this is, to a degree, it's an excimer process, but you can do this with ultra-short pulses as well and potentially achieving better quality, but getting a real direct one-to-one comparison about throughput, speed, and quality is not easy to achieve. And the UV Center of Excellence can do this today and can get to real good results and see what benefits there are for different technology. They're investigating polymer structuring with 2D phase masks, creating really, really small structures, in this case, 350 nanometer structures on a 950 nanometer period with 1 million structures per second. And they're doing this both investigating these technologies with excimer and with deep UV USP lasers to identify what benefits each technologies have. And it's rather interesting because it's not only driven by a clear customer demand or a clear business case, it's also driven by the question, what is possible today? What are the edges of what we can achieve with this technology that we have? What might be interesting to follow up on? And that's a resource that is really valuable. And having the time and resources to ask these questions and get answers to them has been really valuable. Although there are applications that then go directly into the market, like, for example, ABF hole drilling with 266 picosecond lasers. ABF film, very important for microelectronic semiconductor applications. And the ILT, together with us, developed a process here that is now being established in the market today. So these are only 3 examples of things we are offering, or things that are being investigated today. There's a long list of other things like defect centers for qubits, for example, to just name a few, micro LED assembly. A lot of topics are currently being addressed at this UV Center of Excellence. And it's one of the key places to make direct comparisons and find the best solution for your laser micromachining process with comparing high energy, excimer, ultra short pulse, UV on DPV laser systems. So to closing out, the cooperation between Coherent and the ILT Fraunhofer is dedicated to develop the laser processes for the industries of tomorrow. And we'd be very excited to have you join us and work with us at the Center of UV Center of Excellence. Thank you.
For anyone who has been to Aachen, next time you go there, visit Fraunhofer ILT and visit the laboratories. It's simply fascinating. Fabian, representing Coherent, one of our key star corporate members. What can we do for you? What can you do for us?
Well, what we can do for us in the context also of the UV Center of Excellence, I think what we can provide is cutting edge laser technology with industry-proven laser designs. And with the UV Center of Excellence, we can provide a location where ideas can be tested, where new process ideas, new applications can be investigated on a very high level very early on. So I think that's something that we can provide today, and we'd be very interested to work with customers.
And I think we cannot have a meeting on laser micromachining without having one of the industry leaders on laser micromachining in the room, a person who most likely is going to want to talk to you about some R&D cooperation and that lab. Uwe Wagner from 3D Micromac. Thank you very much for being with us today. Uwe, are you with us? Yes, he is.
Yes. Thank you. So what is 3D Micromac? We are setting worldwide standards with our laser machine solutions for a wide range of different applications in the field of laser microprocessing. We typically develop with a huge group of engineers innovative processes with and for our customers. And typically, we substitute established processes with a completely new approach, or even enable entirely new products with a certain laser application for our customers. In order to achieve that, we typically accompany our customers from their beginning of their product development through the process of evaluation and development of the laser process itself, up to the definition of the final solution, which is actually the machine at the end of the day. And to install these within the production chain and the production line of our customers. So the focus with that is usually the process stability and efficiency and productivity of that. So our laser micromachining excellence is not limited. So we don't understand this only exclusively for ultra short pulse lasers. So we utilize all wavelengths and all pulse durations. So even from continuous waves up to femtoseconds, from UV up to infrareds. So with all these, we do laser micromachining, and we always consider the individual process requirements and the process material behavior in order to pick the right laser and optical beam paths. So namely, our machines enable our customers to drill, cut, structure, anneal, and process any kind of material. So a very broad and wide range in different applications and industry sectors. So regarding this, whether our customer is using a certain predefined Micromac product or a purely customized solution, we see and understand ourselves as a long-term partner with the ability and the expertise to develop and supply a complete solution, even around the actual laser process, and to support it through the entire lifetime, and this worldwide. So that's really Micromac.
Thank you very much, Uwe, Fabian. This is the most exciting part of the meeting. This is when we start having a debate with different technologies that have been presented so far. And to start that debate, I'm going to allow me to go to a company that few of you have heard before. This company is called Marco Laser Solution. Who has heard of a company called Marco Laser? I have. And so Jose, Helena, allow me to give the floor to Dr. Reddy. Dr. Reddy, you have posted a very interesting question in the chat. Could you voice that question yourself?
Hello, I'm audible to everyone?
Hello.
Yes.
Hello, am I audible to everyone?
Yes, we can hear you.
Okay, so I'm curious to know, for a given laser system, for a given laser source, so which optical module is best suitable for what thickness? Has anyone done any comparative study?
We are
Especially,
comparing hollow or diffractive optical elements with Skylab's MPLC beam shaping solutions. We may be comparing apples and oranges, but however, I want to get the feeling of the integrator, the end user. Thank you very much, Dr. Reddy, for posting this question. This is all open for opinions. What happens in the next 20 minutes stays in the room. Let's open the room for discussion. Nathan, tell me, what's on your mind?
Hello, Jose. Nice to see you. It's been quite a while since I participated in these meetings. So yeah, basically it's an apple and oranges comparison. Thank you for referring the question to me. I think we should also have Gwen here. So when we're talking about laser glass cutting using usually a type of filamentation process, what we need is an extended depth of focus and a tight focus. So to make this comparison meaningful, you need to compare optical systems that reach the same spot size, yeah, and have the same depth of focus. Now, maybe Gwen can...
Definitely, yeah. Actually, there are multiple options on the market, as it's debated actually in the chat, but I find it a bit hard to follow the chat. There are also English solution providing this type of shapes. And to my knowledge, I don't know any clear comparison in between technologies. When we did some comparison, we did not compare the complex bezel beams as the one that, and is I guess debating also in the chat. And we also have some solution which provide complex. I would say it's nice to try to compare. Trump is proposing the application lab, so I'm happy actually that Trump is paying for the test for comparing all the technologies if they want.
Right.
Thank you, Trump. Thank you, Mr. Leivinger, for funding this potential competition. But allow me to go to one company who has tried different beam shaping solutions. Let's go to Poland. Let's go to the company Fluence. Ilya, are you with us?
How are you doing, guys? Nice to hear and nice to see many people from the industry. Yeah, it was nice to see guys from Power Photonics and Hollow. So we actually have experience with both of these devices for micromachining. So we actually used it with just 20 watts femtosecond laser and reached quite competitive cutting speed in case of glass cutting, and we reached the 190 millimeters per second with 4 millimeters glass, even thicker than you compared. So thank you guys from HoloNet, very nice tool for it. Yeah, and guys from Power Photonics, we use it for polymer cleaving. It's actually quite new application. We were first who showed that in the industry. I don't want to say that we developed that, but we were first to show it in Munich at last Laser Water Photonics. So it allows us to cut cleave polymers with around 500 millimeters per second, which is quite competitive in comparison with CW lasers. And we did it just 20 watts with a 20 watts laser, femtosecond, just break zero. Can you imagine what we can do with 60 watts and 100 watts, Jasper?
So Scott is here also from Power Photonic. So now we have the MPLC technology of Skylabs. We have the diffractive optical lens from Hollow. We have the direct laser writing of the Asphericons coming all the way from beautiful Scotland, from Power Photonic. Scott, what do you bring to the table?
Thank you all for answering. I wanted to just have one follow-up question. Can I ask?
Yes, please, go ahead.
So, I understand that we can't compare the apples and the oranges. So the reason why I asked is because one is based on the diffraction and other is based on the refraction principle. So here, what my question was for a particular thickness. So maybe hollow may be more useful, and for a particular different thickness or for the different glass type. So Labs might be much more useful. So that's what I was more interested actually. And also, just now I got to know that even the power pattern is also they're also providing the similar solutions for the glass cutting, so for the bezel beams actually. So like if someone could work on the same thing, it would be of very much helpful for the system integrators to choose from the like right optical module for the building the system actually.
If I may comment.
Yes, please.
Yes.
So both us and I guess also Labs, we offer a variety of depth of focus options. Yeah, so
yes,
it depends on the angles of the Asphericon and the specific building of the module. But as you see, I probably see in our website, and I'm sure it's true for the other competitors, we all offer a range of depth of focus in air, which translates directly to depth of focus in glass. So the question, what is suitable to you, is just choose the correct solution. But of course, if you're using something that generates a standard natural, let's say, a bezel beam, you're not using the energy optimally, let's say. And
hold on, let's
again,
go to the laser company, because otherwise we're gonna get lost. Every technology has unique selling points. Light conversion. You have worked with many different beam shaping solutions. Could you help us get a good answer for Dr. Reddy?
Well, I just maybe want to extend the comments on what was also commented here from the hollow OR. So typically, once you are trying to address the different thickness of the material, you want to elongate the beam to affect a wider area. And for that, where you need to focus is more on the pulse energy out of the laser source and not the power level. So sometimes it gets overlooked because those two parameters interplay a little bit. So mostly the pulse energy helps you to penetrate deeper into the material, while the output power helps to improve the throughput. So just a comment for picking up the right strategy for the laser.
I think we need is to draw, I think Nathan, Gwen, Scott, we need to draw a table with the different beam shaping solutions and then some of the applications, and make it a bit clearer for the companies like Marco Laser, that is a system integrator and is looking for solutions for their customers in automotive, in medical. It is great, Dr. Reddy, to have you with us. And let's work on that. Let's work on that. But in the meantime, allow me to continue with this meeting, which has been fantastic so far. And for me now, I want to give the floor to another workstation manufacturer. We go again to Lithuania, my favorite country when it comes to laser, to meet the company Aronia. Thank you very much for being with us today. Tell us what you can do for others and what others can do for you. The floor and the attention of everyone goes to Tadas Kildusis.
Hello, everyone. Very nice to meet you. Very nice to see an active chat, an active discussion. So I'd like to show a little bit of what we do, and also okay, should be seeing my screen, hopefully.
Yes, we can.
Okay, perfect. And also a little bit of my view of what I see towards the trends. Maybe that's because we are participating in that. So Aronia builds laser machines. We are doing that for 14 years, and as befits Lithuanians, we do that in ultra short pulse lasers, femtosecond, picosecond applications and lasers from the very beginning. Because we are in Vilnius and because we have all the ultra short pulse laser companies here, Expla, Light Conversion, now Litilit. So we are the ones that are trying to come up with new ways how to use them, how to do things with it. Also using the ecosystem that we have here from optics to lasers and applications. And specifically, now we focus a lot on SEO technology. I'll talk a little bit more about it, but basically, we can selectively plate copper on any material. Also, one of the interesting areas we are looking is intraocular lenses, what Lasea also mentioned for medical applications. And then what we could say more traditional applications with solar, which we have done for quite a long time, and glass, semiconductor materials, color marking, etc. Now, what we see in the laser micromachining market is that a lot of the applications and a lot of things are becoming more and more mature, and it's more of the same, I would dare to say, where we are doing the same processes, but doing it faster, cheaper, and not necessarily new. And the new applications that are coming are not necessarily something new being done, but becoming commercially viable, because we can do that at a larger scale, cheaper, or a little bit better, because of the growing laser power, which in the last 10 years, probably for the same amount, 10 years ago, you could buy 4-watt femtosecond laser. Now it's 40-watt. We have the beam splitting. We have beam shaping for using all those high powers. Maybe just the bus, which we see as a potential innovation in the laser sources, which could bring really something a little bit new. Though a lot of the appeal is also in just making current process and current applications more efficient. So my question is, so where are the new frontiers? So where are the really new applications? And I think that becomes more and more into that interdisciplinary area where it's laser plus something, and then we can find some interesting combinations. And of course, the widest area for that at the moment probably is in laser plus chemistry. So of course, we have selective laser etching, where it's now used for vias, for microfluidics in glass and 3D shapes. We have polymerization for some nano printing applications. Where we are working on that is with our SEO technology, where we selectively plate copper with the help of laser. And probably there are some other applications, and it would be interesting to see some new developments in those interdisciplinary areas. With our SEO technology, what we do, we structure surface with a laser, and then when it goes into the chemical process, copper sticks only where we did the laser processing, and we can do that on pretty much any dielectric material. So on standard electronic materials that are used currently for PCB, or on other materials that are coming into electronics market, like glass or ceramics, a lot of different polymers that are using now in semiconductor packaging. And that's how the process looks. So as I said, really a mix of laser process and chemical process. And what can be done. And we see that area as one of very high potential areas, and potentially a big breakthrough in electronics manufacturing and also in semiconductor packaging as well. And I'm pretty sure that in that area between laser micromachining and together in combination with something else, there must be some other applications as well that are not yet found out. So I see that as a very interesting area to work at and to look for new applications. So that's my short point that I wanted to bring to the meeting.
Thank you so much, Tadas. That's actually a very good question, and this is like we heard it before, like where is this laser micromachining going? So what is going to be the future? What is going to come? What is going to be the new advance, the new technologies, or the new applications in this case too? So my question to you is like, then for the people, what do you need? What do you need for the people that is here in the floor to move forward in laser micromachining? For what are you looking for new applications?
Well, obviously, laser source is always a big component. I think we are quite well covered with the local manufacturers as well. But also all the beam shaping and faster scanning solutions where the throughput could be increased. That's a very interesting area. Another interesting area for beam monitoring for what's really happening on the sample when we are fabricating, so we can make a closed loop fabrication and really control the process and make sure that it's correct at first time.
So we have here in the room from AKS Marcus. Marcus, do you have something to say about how to do the monitoring of the bin? Marcus, are you available? Doesn't look like. Okay, well, but we continue then. For
Sorry,
you know. Oh, here you are.
Yeah, I couldn't find the button for unmuting. Sorry for that. I mean, there are several solutions in measuring the lasers upfront the application with our OFI instruments, obviously, but you also can measure during the process, which is a little bit more tricky if you work on femtoseconds. But we are big fans of knowing what the laser is up to before putting it into operation and wasting energy, material, and all of that. So knowing the laser before the process is important. And of course, knowing the laser in the process is another thing. But this is a very quick response to your question.
Yeah, thank you so much. So we also have let's talk a little bit about the lasers before I go to Turner. So we have Heather from Trump's. So I would like to see what is the point of view from Trump's in this, and what they can do for these people. Heather, are you around? Heather, hello. No, Heather? Okay, let's continue then. So there is also, I mean, we have basically a very good representation of all these high energy lasers and very fast lasers. So let's go to France. Let's go to Amplitude. So Quentin, tell us what you have for us in laser micromachining. Show us.
Yeah, can you see my screen?
Not yet.
Yeah.
In 3, 2, now.
Okay, so I'm continuing with Amplitude. So Amplitude is a femtosecond manufacturer, and we have seen the evolution actually of micromachining since the past 20 years, basically, with low power, like a few watts for eye surgery application, up to higher power used for display application, for example, or for watchmaking, and the use of higher power, like in the 100 watt, in the 100 watt range, for splitting beams and be used for cutting LCD screen, for example, or wafers. And lately, we are facing is actually what reported Rose, for example, is the application with high power, so like a 300 watt laser up to kilowatt laser, is the challenge to go to new macro scale application like metallurgy, battery application, data storage, and aeronautics. And on this, thank you.
Yeah, thank you so much. Thank you so much. So as we see, I mean, this is kind of the conversation. So everything that is going to miniaturization is going to need laser micromachining, and then we are going to have like different materials or traditional materials. So this is the kind of conversations that I would like to know where every people here in the room is thinking
Helena,
about.
we have a question coming all the way from Disco. Benjamin, what's in your mind?
Yeah.
Yes, I really enjoyed the discussion between Holor and Gwen or Kelly Labs. And I was wondering, after the modification, how do you realize the separation? Just by breaking or at a certain thickness I mean, we of course think a lot about tape expansion, but maybe you can comment quickly on that. I mean, just simply the doing modification, I guess, is not enough to divide the material into two.
Benjamin, the question is to whom?
To Huloa and Gwen, I think, because I followed the discussion in the chat.
Yes, I think I can make a quick one until Nathan put his mic on again. Definitely on our side, it was not enough. And as you said, there is some mechanical strands to apply on the glass to cut it afterward, which is, I guess, typical when you're using bezel beams. So as far as I know, none of our partners has found a way to avoid that part. Nonetheless, the whole point was not to avoid it, but to find more complex drilling. For example, we can try to control exactly how deep it is, how repeatable it is, decrease the roughness. This is the type of challenge we were looking for addressing on our side.
I mean, if this competition really happens on the trumped application, I would be happy to do the breaking and then deliver the force values that was needed to separate the parts. Of course,
in a way,
as lower force as needed would be happy for it. Yeah.
In a way, I would be happy it's happening too. I'm always happy. I mean, comparing is always anyway good, and we should compare apple to apple. As Nathan was saying, it's super important and not often done when it comes to beam shaping. Nonetheless, I think we should find someone more neutral than Trump in the end. So if there is someone motivated around who finds himself neutral, that would be probably better.
Yeah, that's good. Now that we know that Heather is back, so and knowing that Trump is going to pay for it, so Heather, could you please comment about it? Heather?
You know, Helena, one of the things that is the most exciting about working at Optica is that you get to work with our friends, with our best friends. So allow me to wait for Heather to give the floor to one of my best friends in the world, Caro Maestro, Antonio Raspa, Luxinar. Tell us what you do and tell us how others can help you doing things you cannot easily do yourself. The floor and the attention of everyone goes to the Maestro of Lasers, goes to Antonio Raspa from Luxinar.
Okay, thank you so much, Jose, for the nice introduction. I'm really happy to be here because I'm really happy to talk about laser technologies. And normally I talk a lot, so let's start from the end. What I can do for you and what you can do for me. Let's start from the end. And also I provocate you, Jose, and are really this the right question? Probably is much better to say what we can do together. That is probably the key point. Together means all together, like we are in this meeting, and this is very important. Talking together, discussing together, and this is extremely precious and welcome. So we are speaking about Luxinar. Luxinar is manufacturing industrial laser since 1998. And what we developed for ultra short pulse laser is the concept of the platform. So is a platform means that we have a system that we can decline in different laser power level and also different wavelengths. It's important to note that some of the features that have been asked before by Ben and also by other speakers before, like pass on demand, external gating, full control of burst and fast burst mode, as well as an interface available to drive the system, are already in the platform and are available for any type of laser. Clearly, there are also some important features that are the laser features, like beam quality, power stability, and so on. But this is also important when we speak to end user or to people that would like to use laser. It's important that we start to speak their language. So if we are laser specialists, we have to provide some solution with several choice on the power level and the wavelengths. Also, we have to make them an easy life. They should not be worried about the laser. So it's very important to have very stable and consistent beam quality. So the end user should not be concerned to check what is doing the laser. The laser is running as you take a car, and what is doing a car? Just bringing you around. You have not to take care too much about the details of the car. Clearly, as a car, you step into the car, you warm up the car 5-10 minutes. In the case of the laser, here we're speaking about 15-20 minutes, and then the laser is repeatable. Repeatable after 2 minutes as well after 60 minutes or the day after. When you switch off the experiment or the production, the day after you start from the same point. And this is probably something that is under evaluated. Power. Most of the people are speaking of power, but it's very important to control the power of the laser. But not because it's the power of the laser, but is how you deliver the power into the working piece, on the piece that you have to machine. So the control is very important, and also how you control with the machine. A key feature is how you deliver the pulses in time. Here you can aggregate pulses in burst, and also you can edit the single pulse in the burst in a different way, and you can obtain very different way to put the energy into the part, and these are driving the quality of the resulting material, of the resulting processed parts. As I said before, it's important to make easy to work with the laser. Honestly, I am in love with laser since 35 years, but the laser is nothing else than a tool. So we must really put to the lowest level and make it easy to work. And the LXR platform has 2 levels. Let's say standard user level, so they are very easy and easy to manage features and function. And then there is the advanced user, so like the people from maintenance as well as from R&D or process engineers. They can work more on this level. Laser is a tool that normally is integrated into a machine, so it's very important to think on an easy integration. So the interface probably is redundant. So here you can drive the laser in a multiple way, and the key points is how you synchronize, how you control the laser from the machine. Just a simple note. Also, it's very important the footprint. It should be very easy also to put the laser into a machine, and also to have the choice to select a different type, a different model of laser without redesign the machine. So the platform is offering the same footprint for every type of models and every level of energy. Okay, here we've spoken already about application. So we're really the potential of a laser, and especially of ultrafast laser, is limitless. It's not the matter here to discuss. So just briefly, let us know your needs. Let's talk together, and we will provide a solution. The solution to solve the problem of the customer.
Thank you so much, Antonio. Thank you so much. I mean, Luxinar have been like proven to do all the laser micromachining very well, all these applications with high precision and basically no waste, which is also another part of it. One of the parts that we have a question actually from Ila from Fluence. So Ila, can you open your mic and ask yourself?
Yeah, hi guys. Just we focus on burst modes, and I'm curious what's intra-burst interval in Luxinar femtosecond lasers, because it can be beneficial in stance industry to avoid plasma shooting if you can control intra-burst interval.
Yeah, so the inter-burst distance is 25 nanosecond. Is 40 megahertz the key seeder, and the intra-burst minimum separation is 200 kilohertz.
Yeah, we just learned that actually 50 nanoseconds can be beneficial to avoid some problems in processing in case of burst mode. But 25
Yes,
is kind of
I would
standard.
say I fully agree, and yeah, that's the point. To be honest, femtosecond laser it's a quite cold technology. It's not a perfectly cold technology, because at the end you put energy into the parts, so at the end you interact with the material. The point is really how you manage, how you control the input of the energy into the path. So also it is very important that you can also edit the single pulse in the bus whenever necessary.
Yeah, you have to find optimal fluence, also energy density.
Yeah, the energy density. So it's a multidimensional problem or universe. It's not really it's not a constellation. It's a universe of parameters.
Yeah, thank you so much. So we have Heather finally back. So all the problems.
I'm sorry, I couldn't
no, it's okay.
unmute
Please.
earlier. So just quickly, yes, we do have a 2 millijoule laser in our lab for glass processing. And sorry, Gwen, we probably aren't going to do processing for other solutions, but we will do that for Dr. Reddy or other people who are interested in those capabilities.
Thank you so much. So so now something that we have to consider also, we haven't talked about that is what
Sorry,
about, tell
Elena.
me.
No, just a point, because we were jumped to glass, and the question about how to separate after me. So a quite old technology is to use a second laser, the working horse, a CO2 laser. So with the CO2 laser, you can manage to put a suitable heat into the same track that you machined before. So you manage to transfer the thermal load into the track and you separate. This is a quite old technology, but is still widely used.
Still working.
It's working, and it's working. And this again is a laser. Maybe are not so sexy to speak about CO2 laser, but I would say CO2 laser will never die.
Sort of, yeah.
We very much hope so.
Yeah. So something that we haven't touched too much is also, I mean, who is doing the optics? So what about Asphericon? So Asphericon is I mean, a big optics manufacturer, all shapes, all materials. So please let me introduce you to Sebastian Henkel, the head of global sales at Asphericon. Sebastian, the floor is yours.
Thank you very much for the kind introduction. And yeah, so it's going to be a rather quick one today. And then you already gave the introduction. So we obviously are manufacturer of optical systems, optical components, stuff like that. In terms of rotational symmetric optics, spheres, hexagons, but also monolithic designs. In the meantime, we process all the common materials from fused silica up to polymers, metals, stuff like that, from UV up to the infrared wavelengths. Out of that, we derived some optical systems for our customers, OEM customized systems for high power systems, such as high-NA objectives. We also applied high-end finishings on those kind of systems. And as a consequence, about more than 10 years ago, we derived some standardized products in terms of beam shaping, beam expansion, where we basically have a smart toolbox where you can combine any kind of beam expanders, beam shapers, put them just together, play around, tweak them a little bit according to their needs, to the needs of the customers. They all work diffraction limited in all the major wavelengths. So starting from 355 up to 1064. And just to give you an impression of how a typical setup looks like. So on the bottom right, you can see it, some examples of how those elements can be combined. And on the top right, you can see we are able to use fiber coupled sources as well as free space lasers to generate a collimated beam, then shape it, for instance, into a top hat, and then afterwards scale it up or scale it down for whatever the needs are. So this is just a quick overview of our very simple to use, very high performant beam tuning systems. And yeah, happy to know about your applications and learn about the challenges. Thank you.
Thank you so much, Sebastian. That's actually very good because I mean we all know Asphericon since a long time, and again, so beam shaping is one of the key things that we have in micromachining if you want to control the tip, don't have it crash, and all the things. So. Thank you indeed. So we have also a question that is coming from Lars Manesh. Is asking to Benjamin. Lars, could you please open your mic and read yourself?
Well, hello. Yeah, I mean, what's really important in laser processing, especially when you go in really small features, is the curve loss, and this is all about spot size, I believe. So how can we basically optimize that? The quality of the optics, for example, this is really important. The wavelength of the lasers is really important, and so on and so on. So yeah, this is basically a question. How can we reduce curve loss in general?
Benjamin.
So you're referring to the curve loss for the Cabra process of the silicon carbide splitting? That's what you...
Yes, indeed. Yeah.
Yeah. This I would rather discuss in person. So
please contact me. Very interested. Yes.
Thank you.
Lars is the first time you come to this group of people. Please say hello. Tell us what you do. What is PSSP?
Well, I have set up PSSP a few years ago as a photonic supply and services partner. It's all in the name. So I want to accelerate the adoption of photonics in industry and academics, and to boost basically the problem-solving capabilities and innovation potential that our very valued technology has. And yes, this I do with OEMs and universities and startups. So I'm really excited about photonics and the capabilities and pushing the boundaries.
Thanks. Oh, thank you. Yeah, thank you so much. So that's part of it. Like what we are looking here is to find partnership and working somehow. So again, to try to figure out what you can do for the people and what the people can do for you, and that way we can go together. So everybody happy, Antonio? Yeah. So our next speaker is coming all the way from San Francisco, so from the Bay Area. So this is pretty early for you. So thank you so much for waking up so early and stay awake all this time, all your attention. So is Mark Turner, the CEO and founder, the Turner Laser System. Mark, the attention and the floor of these people is all for you.
Thank you for the introduction, Helena, and great to see a lot of familiar faces and also to meet a lot of new faces as well. So look forward to connecting with everyone after. Just screen share. So as Helena mentioned, we're based in Silicon Valley in California, and I'll talk a little bit about our company, Coherent Laser Systems, and as well as our partner in automation, Owens Design. And similar to some of my colleagues here, we are a laser system integrator, so we build full turnkey laser micromachining systems. And I'll focus a little bit more today on not just the laser optics and the micromachining side, but also on automation, which is a critical part to high throughput manufacturing. So, just very briefly, the types of tools we make standalone laser micromachining tools. So these are manual load tools where you can input a wafer, a sheet of material. We work with medical devices, variety of different materials for micromachining. We also build fully automated systems. There's often these standalone tools are then partnered with things like a wafer front-end module if you're working with wafers or solar cells. We also build fully custom automated robotic solutions as well to be used with these laser micromachining systems. And then we can also build fully 100% customized laser micromachining solutions for a variety of applications. It really depends on the application of what type of equipment would be best to support it. So, one of the wonderful things that we see here in the micromachining space is that it gets to serve a variety of different industries. Based here in the Bay Area of California, we see a lot of work with medical devices, particularly medical implants, semiconductor applications. Battery is a very hot area right now where we're seeing a lot of new materials, a lot of very challenging materials to process, and micromachining has a huge role to play in the battery and energy industry as well. For solar manufacturing, particularly scribing and dicing of solar cells, we're seeing a lot of micromachining applications there. And of course, consumer electronics, display, VR, AR, they all have manufacturing challenges that leverage micromachining today. So, the types of lasers, optics, processes we work with, kind of listed a long list of applications here. I'd say at Turner Laser Systems, we primarily work with femtosecond lasers and picosecond lasers, so it's great to see a lot of conversation here today on those. But we still do a lot of work with nanosecond, fiber CW, and CO2, often as a complementary laser source to the ultrafast lasers. And the types of processes we'll do involve many different types of processes, including ablation, cutting, dicing, drilling, etching, micromachining, welding as well, to just name a few of the core processes that we'll work with, and across a variety of different form factors. So one of the fun challenges we have in the automation space is working out how do we not only use the lasers, but how do we bring the materials and handle the materials in unison with the lasers and bring it all together. So something I'll talk about a little bit differently today, instead of diving deep into the types of applications and processes, a little bit more about the philosophy for how we approach this. And I think this is very complementary to the discussions that we've been having today on optics and lasers, is how do we go from, all right, I have this application, which maybe, we were just talking about glass cutting before and using different optics there. How do we go from these creative ideas to a solution that's ready for 24/7 industrial manufacturing? And one thing I'd like to share with you today is our phased approach that we highly recommend to use in the industry, because there's often a big gap between a quick test that's done in a laser lab or applications lab and having the solution ready. And we often like to break this into critical phases, really sort of it's a program management approach where we look at the risks, we look at all the challenges that manufacturing would have. And this is a really critical step. We don't just look at the laser processing side of things. We also look at the manufacturing side of things as well. Things like, how are materials going to be fed in a manufacturing environment? Do we have tolerances to the materials, different thicknesses of materials as you go from batch to batch? All these really critical nuances in manufacturing that are really important to understand, and really recommend for those of us in the laser industry to work very collaboratively with automation. This will be a critical step to avoiding the infamous valley of death, where essentially, manufacturing lines sort of power up and you have this equipment running and the laser processes and systems just aren't meeting the specification if you don't consider things carefully. So we have a methodology for doing this at Turner Laser Systems and Owens Design, and this is really based off of a 40-year process that Owens Design has built, where they look holistically at the technology, manufacturing, and business needs of a specific application. And then we break it down into critical phases. And often we'll develop these laser processes. We'll try different optics, different lasers, different setups, fixed string, airflow, they all make a big difference. But a lot of the times we'll develop that in parallel with the automation, and they go really hand in hand. And a critical thing that we've learned in years of working together with Owens Design is not to develop process or laser technology in a bubble, and really to work collaboratively with your automation teams, understanding things like the upstream and downstream process needs is really critical. And this has led us to great success in deploying these solutions in large volume manufacturing. Just a little bit about our laser platforms that I mentioned. We're a custom laser machine builder, so we tailor these machines to the application. And here, what we're trying to do is select the appropriate, laser optics for the application, so to maximize the ROI from a commercial standpoint. And a lot of the work that we do in developing these phased, development projects go into that tailored configuration in all of our machines. Here's an example of one of the machines. I think Dr. Brady was asking about glass cutting. This was actually a machine that we had built that had glass cutting built into it. This was for a medical application, wafer scale. This was also doing via hole drilling and glass-to-glass welding, glass-to-metal welding, and some ablative processes as well. Really critical to these types of processes, we haven't really talked a lot today, are things like motion control. So motion control, precision motion, things like vision systems, sensors as well, because a lot of times we have to measure the part before we can process it with a laser. We've been talking about things like high numerical aperture optics and things like that. It's really critical you have your laser in focus and on the part. So bringing all of these technologies together into an integrated solution is really critical in manufacturing. Besides the laser and the laser process, often being able to feed materials into the laser machine is critical. And, understanding things like, am I able to process the material from one side? Am I allowed to flip the material over? Can I handle the material in certain ways? All of these constraints that we have in manufacturing really affect the process and the laser solution that's going to be applicable. So we provide these automated solutions for feeding materials into these laser machines as well. And then we can, of course, do things like the factory automation to communicate between our automation systems and the full factory. And besides just standard wafer loaders, we can also do fully custom automated solutions. And this was an example of a battery material processing that was done essentially and involved robotics, automated loading, unloading, laser cutting with femtosecond lasers, galvo scanners, coordinated stage motion. And then we had to post-process. So we have to clean the materials afterwards, remove the debris. Most of these ablative-based processes are going to create debris, and there needs to be ways to handle, mitigate, and post-process remove. So that's briefly about our companies. And nice to meet everyone here. And in terms of what can we do for you, what we can do for us, we're really looking for partners, whether these are customers and users, suppliers, who sort of align with this philosophy of approaching things systematically, methodically, and working through developing things to create turnkey manufacturing solutions. So, thank you.
Thank you very much, Mark. And the story of Tunnel Laser Systems is actually pretty cool. And we just wrote an article for Laser Focus World. It's going to be published in the next edition, in which you can find everything about this company. But Mark, and also Jose from Lasea, in previous discussions, we talked about the state-of-the-art on femtosecond laser-based surface structuring, hydrophobic solutions, antibacterial surfaces. What is the current state-of-the-art on this? Are we ready to develop this for large surfaces? First, Mark.
Yeah, I mean, a lot of the challenges I've seen over there is the surfaces often aren't flat. So, having motion systems with multi-axis control, metrology is really critical in those types of applications. And so I'd say the applications we've worked on, we've had to do three-dimensional surfaces, even getting inside holes or grooves and channels in those cases. So the motion control has to be one of the biggest challenges.
Jose, you work in the LAMPAS project funded by European Commission for a few years, working together with Bosch, with Trumpf. What is the current state-of-the-art of femtosecond laser-based surface structuring?
Yes, in fact, the activity is followed up with new projects like Operatic and Syntex nowadays, because it's a very interesting subject. It's known since long time ago, with the first publications from more than 15 years ago saying that we will generate, for example, anti-icing surfaces for planes, something very promising. But when we performed the tests, the trials at the lab, until a few days ago, you achieve maybe a square centimeter in half an hour or 1 hour. This is very far to real world applications. So the reason for that project was to try to take advantage from one side from higher power levels from one side and other engineering techniques in order to handle the beam and be able to generate those hydrophobic, for example, functionalized surfaces at higher rates. So if I'm not wrong, the project ended 1 year ago with a demonstrator that is still at our facilities in Liège. Something close to 1 square meter per minute in the lab.
Did you guys hear that? 1 square meter per minute in the lab, but 1 square meter per minute. Allow me to bring to the table 2 lasers that for me have meant a lot in the last years. They are called the carbide and the pharos. They are coming from light conversion. Aurinas, I know in the past we discussed a lot of surface structuring. Please share your screen, tell us what brought you to this meeting, and send us off the way that we deserve.
Hello, everyone.
Hello.
I hope you see the screen. So happy to give the talk and a short presentation of the intro and the company. So actually this year we are quite happy to celebrate our 30th anniversary of the company. So we are in the market for already 30 years. And maybe the key point that we are trying to do and focusing is we focus on femtosecond technology mostly and specifically. So this is our key business and area of expertise in both scientific and industrial areas. Well, since this seminar is mostly dedicated to the micromachining, where we'll be mostly maybe discussing the industrial type of topics. Well, maybe some highlights about the company is that we are currently doing around 100 million in revenue, and in our view, we have probably one of the largest workforces dedicated for femtosecond alone in the industry, which we now exceeded more than 550 employees. And well, we are up until now see that we are working in a very rapidly growing segment of the laser industry, which enables us to grow for a compound growth for at least 20% each year for the last 5 years. Also more focusing a little bit on the products that we are delivering as you know, it was mentioned before, those are mostly the carbide and pharos femtosecond lasers, which are used for a variety of applications. Maybe the position of our company is not to dive into the applications on our own a lot and rely on a lot of partners, such as, you know, we can find many in this meeting. And our core competence is supplying OEM laser solid state to the industry, which would then enable our integrators and partners to finally chase the applications. So some points is that due to the solid state technology and regen technology, we can identify ourselves as very high pulse energy capable laser systems with adequate power levels, and also including our excellence, since the name of the company is light conversion. We are known very well for converting light into multiple wavelengths. So we can offer industrial solutions up to the 5th harmonic. So maybe that's a short intro, and I hope I didn't steal too many time.
Thank you very much, Aurinas. For everyone in the room, the market for laser systems is still a big unknown. For many years, we didn't have a good laser report for the laser industry. Remember, this year, Optica released the laser report of thematics free for all corporate members. We invested quite a lot of time and effort, and many of you were interviewed for this report. Please download it, check it, and tell us how to do it better. We are very proud of the result of this laser report. And with this, I would like to tell everyone, it has been a great couple of hours. Thank you very much for making this event a success. Until the next time, stay healthy and see many of you at OFC and many of you later on this year at the Global Photonics Economic Forum in Malaga, 1st and 2nd of October. Until the next time, take care and stay healthy.
Bye, everybody.
Bye, everyone.
Okay, thank you very much for a great meeting. Allow me to undo my tie a little bit and breathe. It was great. Now, if you have to go because you need to take the children from school, or you need to start cooking dinner, or you simply need to relax a little bit, or if it's early in the morning for you and it's time to start working, just leave. It's okay. If you want to have a little bit of a follow-up discussion, stay and we can have a quick